get your calculator ready because I will show you guys how to use your calculator to solve tricky equations. And make sure your calculator is in the degree mode. Here, first one, sine theta is equal to 1 over 4. This is not on the unit circle, so it's not a special angle, but it's okay. We can take the inverse sine to get the theta by itself and use a calculator. You'll get about 14.5 degrees. And then we're done, right? Well, no, not too fast. Because on this interval, in fact, we'll have two angles that will make this true. What's the other one though? Because inverse sine only gave me this, right? Well, here's a much better way to understand it. Instead of just try to memorize the other answer is 180 degrees minus that. Let's have a look. Sine theta is equal to 1 over 4. The 1, treat that as the opposite, which can be labeled as y on the xy plane, of course. And then the 4 is the hypotenuse. We will call that r. We can draw a reference triangle like so. 1 right here for the y value, and then from here to here is the hypotenuse, and that will be 4. So based on that. And based on the inverse sine function, we know that this angle is 14.5 degrees, which is very nice. Yes, this right here is the first answer. Theta is approximately 14.5 degrees. But the reason that this is not the only case is that not only this right here is y equal to 1, but we could also have been right here, right? So we could also have gone the other way. 1 being here and 4 being right here. However, when we measure angle, we always have to start with the positive x-axis and rotate to the terminal side to get the angle for that. Well, earlier we only have 14.5. It's just a reflection, right? So this little angle has to be 14.5 as well. But how about this red angle? The whole thing is 180, just minus that, and that's it. So the other answer, theta, I'm just going to say that's going to be equal to 180 degrees minus 14.5 degrees. So you can see theta right here is approximately, I really don't know if I should use the approximation symbol or whatnot, so I will just keep approximating, I guess, because that was an approximation anyways. So here this is going to be, I could have just subtract, but anyways, I look at my notes, 165.5 degrees. So two answers on that interval, and this is how you get it. It's not always true. You do 180 degrees minus the angle if you're dealing with cosine or tangent. So let's also take a look. Here we have cosine theta equals negative 1/3. Yes, let's go ahead and put theta equals inverse cosine and just enter that inside. And then use a calculator. We will get approximately 109.5 degrees. Quite nice. Notice that this answer is inside of this interval, so we are good. But yes, there's another answer. How do we find it? That's the question. So let's analyze it again. But for cosine, instead of being y, we will have x. And then this right here is still r. Because this is the adjacent over hypotenuse. So I'm just going to say x is equal to negative 1. And here is a picture for that. Well, x is being negative 1. It's just to the left a little bit. Let's say right here, negative 1. And the r is 3. So I'm just going to kind of extend it to like this. This is like 3. And here is my triangle. The 109.5 degrees is the measure from here to here. And of course the picture makes perfect sense because this angle is bigger than 90 degrees. 109.5 degrees. And that's our first answer. And then we're done. Now, how do we come up with another triangle though? Remember, we will have to keep the x value being the same because r has to be positive. So instead of drawing r like this, we could also have gone like that, right? Yes, so I'm just going to do it like that. So, or I'm going to put the picture down like so. Here is negative 1, and then we're going to do it like this. And then here's our reference triangle. This time though, you can flip this angle down like so. So this angle is 109.5 degrees. Technically negative if you want to, look at it like that, doesn't really matter. But now, again, here is our starting measure place. We are going to rotate so much so we can end up here. So how do we do it this time? The whole thing is 360. This much is 109.5 degrees, right? We just have to subtract it. So theta will be approximately 360 degrees minus 109.5 degrees. And then if you work that out, 250.5 degrees. So second answer, and this is the first answer. So as you can see, this is the case for cosine. It's an upside down reflection. For the sine, it was left and right. Understand the triangles. This is definitely better than memorizing like 180 minus the angle was 360 plus the or minus the angle, whatnot, right? Now let's take a look at the tangent example. So here we have tangent theta is equal to negative 2 over 3. So let's right away take the inverse tangent on both sides. And we will get approximately negative 33.7 degrees. Oh no, because this is not inside of this interval. But don't worry, this will help us to get the answers that are inside of this interval. But how though? Again, draw triangles. Firstly though, we have to understand tangent is what? Opposite over adjacent. And on the xy plane, that's y over x. So we can take y to be negative 2 and x to be 3. That will give us, let me just make a note right here because this is a little bit trickier. Take x to be 3 and then y to be negative 2. And draw the picture. We will have a picture like this. Let's say 3 is right here, positive x, yeah? And then negative 2 is, let's say, right here. And this is the triangle that we have. Negative 33.7 degrees is this right here. Which makes sense, right? Because negative angle, you rotate it clockwise. But now, we will have to measure the angle from the positive x-axis, rotate so much, so we can end up right here. Again, in this case, will be 360, subtract that. Or this number plus 360. So either way, theta is equal to 360 subtract 33.7 degrees. And then just work that out, 326.3 degrees. Yes. So that's the first answer. But now for tangents, trickier because x and y, they could be negative. So instead of negative 2 over 3, we could also have take x to be negative 3, but y to be positive 2. The negative can be looked at it as 2 over negative 3, like this. So based on this, we'll draw another triangle. So we will have this right here. I'm going to put it down like this. Negative 3 will be right here, and 2 will be right here. And this is our triangle. So this is going to be this kind of reflection, right? Go there, 180 degrees. This little angle is 33.7 degrees. I'm just going to look at it as a positive value. And again, we will have to measure the angle from here all the way to here. Theta will be 180 degrees and then just minus 33.7 degrees. And then just work that out. So theta will be approximately 146.3 degrees. Yep, that's it. Believe in triangles.